Hello and welcome to G Fun Facts Online. When we think about going back to the moon, we imagine rockets, landers, and astronauts planting flags. But the single biggest challenge for staying there isn't the journey. It's the power bill. How do you keep the lights on during a 2-week-long, freezing cold night? The answer sounds like pure science fiction. We're going to build a power grid in the sky. You see, the moon has a really long day-night cycle. A lunar night lasts for about 14 Earth days. Your standard solar panels on the surface would be useless for half a month, and temperatures would plummet to below -155 degrees Celsius. Not great for a permanent base. To truly live on the moon, we need a constant, reliable source of power. Enter the grand design. A constellation of satellites orbiting the moon. These orbital power plants would be in near-constant sunlight, soaking up solar energy 24/7. They would then beam that power wirelessly down to receiving stations on the lunar surface. Think of it like a massive, space-based wireless charger for an entire colony. Engineers are exploring two main ways to do this: beaming the energy as microwaves to large receivers called rectennas, or using high-intensity lasers aimed at specialized solar cells. This system could even power rovers exploring those permanently shadowed craters at the poles, places that never see sunlight but are thought to be rich in water ice. And this isn't just a wild idea on a whiteboard. There's a global race to make it happen. NASA's Artemis program sees this as critical for a sustained lunar presence. The European Space Agency's Solaris initiative is developing concepts like a giant butterfly-shaped satellite that could beam megawatts of power down to the surface. Aerospace giant Northrop Grumman is developing sandwich tiles, incredibly light panels that collect solar power, convert it to a radio frequency, and beam it all from one integrated unit. They're even exploring a lunar railroad that would need this kind of robust power network. And then you have the startups, like Volta Space Technologies beaming power with lasers, and Blue Origin, which has figured out how to make solar cells directly from simulated lunar dust. Now, building an interstellar power grid isn't easy. The moon is a brutally hostile environment. First, there's that lunar dust, or regolith. It's not like sand on a beach. It's fine, sharp, and electrostatically charged. It sticks to everything, grinds down mechanisms, and can short out electronics. Then there are the extreme temperature swings, from over 120 degrees Celsius in the sun to that bone-chilling -155 in the dark. And with no atmosphere or magnetic field, everything is constantly bombarded with radiation that can fry electronics. All the hardware we send has to be tough enough to survive this. This space-based grid will likely be the backbone of a much larger power ecosystem. For backup and continuous power, we'll likely see compact nuclear fission reactors, which NASA is already developing. We'll need incredible energy storage too. One amazing idea is using surplus solar power to split water into hydrogen and oxygen. During the 14-day night, you recombine them in a fuel cell to generate electricity, with water as the only byproduct. It's a perfect, closed-loop system. But the real game-changer is In-Situ Resource Utilization, or ISRU, a fancy way of saying living off the land. The ability to manufacture solar cells, wiring, and even energy-storing bricks directly from the lunar soil will slash our dependence on expensive launches from Earth. So why go to all this trouble? Because abundant, reliable power is the ultimate key. It unlocks everything else. It allows for long-term science missions, mining for resources like water ice, and the birth of brand new commercial industries like lunar tourism and manufacturing. This power grid isn't just about infrastructure. It's the foundation for a permanent human future in space. The science fiction dream of beaming power across the void is becoming a technological reality, and it's going to light our way back to the moon, this time for good. Thanks for tuning in to G Fun Facts Online.